Now I want to divide 13 and 2/10 by 6 using the base 10 block model. I will let my square represent my wholes. I will let my lines represent my tenths. And I will let my small cube represent my hundreds. Notice using the model, I can also practice the place value from greatest to least or least to greatest. The model can help do more than just divide decimals. It can also help you to compare place value. All right, based on my dividend, I have 13 wholes. So I want to model those. So I have 13 wholes. And based on my dividend, I only have 2/10. So I want to ask myself, how many groups of 6 do I have in 13 wholes? Based on my model, I have 2 wholes. 2 groups of 6. So I'm going to represent 2 wholes. 6 times 2 is 12. But I had 13 wholes, so I have 1 whole remaining. Before I proceed, I ask myself, how many groups of 6 are in 1 whole? The answer is none. So I want to regroup this 1 whole with my tenths. Now remember, you cannot just bring a whole into the tenths. It must be an equivalent. So I know I'm in my tenths place, but what numerator can I use that's equivalent to 1 whole? And the answer is 10/10. So this 1 whole is equivalent to 10/10. I have 2/10 already here, plus the 10/10 that I regroup. So I have a total of 12/10. And I'm going to model 12/10. Because my lines represents my tenths. So I have 12/10. Well, if I had 6 groups, how many tenths would be in each group? There would be 2/10 in each group. And because multiplication is an inverse operation of division, I can always check my work. The quotient, 2 and 2/10, times the divisor, 6, should give me a product when I'm multiplying that matches the dividend 13 and 2/10 that I used when I was dividing. 6 times 2 is 12. Now, understand that 6 times 2 tenths is 12 tenths. And 12 tenths is equivalent to 1 whole and 2 tenths. So 1 whole and 2 tenths. And 6 times 2 wholes is 12 wholes, and 12 wholes plus the 1 whole from 12 tenths that we got from 12 tenths equals 13. So 2 and 2 tenths times 6 equals 13 and 2 tenths.